right. Are there any questions on anything, especially the design chapter? Any questions? All right. What I wanted to do tonight before the class exercise is something that you should do for next week. It is slightly different from the usual reading. I have posted something on the internet on D2L under readings. It is called implementation.pdf. You should read that instead of the implementation that is in the book, because I have changed the implementation to accommodate some code safety, data integrity considerations. This is something I have been wanting to do for several semesters, never got around to doing it. So you will learn some interesting stuff, new stuff. And for that, you need to look at the reading that is in the D2L site. So it is under readings and it is called implementation.pdf. That is what you should read. I created new videos and posted them for lecture 8. So do all that. And you should become familiar with the code for the library implementation. It is also posted, it should be there under class project implementations. Let me just make sure it is there. I mean, before I say anything more. Yes, it is the class project 1 version 1. So you should download that, open it. You should understand it because you have to implement the project, the group project in a similar fashion. Okay, that is the first thing I wanted to say. Second thing is I wanted to elaborate on in a certain aspect of the design. So we have, I'm going to talk about the design of the library system. So let's look at, let me share the screen first. So what I wanted to do was tell you about the library class. So let's look at that. So we have a number of classes, but what I want to elaborate is the library. So and we also have the user interface here. I'm just going to call it UI instead of writing the whole thing. And there are, of course, a number of objects, number of other classes too, a number of objects. So we have a lot of objects sitting here. Right. Besides the library, there are a number of other class objects also. The library is a singleton. There is only one instance of it. The UI is a singleton. And we also have here, maybe this is the catalog object, which is also a singleton. I mean, actually in the implementation, it is not. So it doesn't matter. There is only one catalog in any case. And here we have oops, what is going on here? Okay, here, member list. And then a number of objects possibly here. This could be a member. Oops. Okay, this could be a book. This could be a second member, perhaps. Then you could have transactions. You could have more books. And so on, right? So there are a large number of objects potentially that the library is working with. So we have the library talking to all these objects. Actually, it should be bidirectional arrow, but anyway, let's not worry too much about those things. So the library is talking to all these folks. And we also know that the library is talking to the UI. Okay, so obviously the actor is sitting here and interacting with the library, with the UI. The actor issues some commands, and those commands are taken by the UI, shipped to the library, and the library returns a result for the operation. Maybe you add a member and the library says, okay, I added the member. The UI might say, add all these books. The library would say, okay, add it. Then the UI would say, issue books. The library would say, okay, I have issued all these books. So there are well-defined operations here to carry out the business processes. So you have add book, add member, issue book, place, hold, remove, hold, return book, and so on. When given a certain operation like issue book, the library would consult a member list, it would consult catalog, it would figure out who the member is, who the books are, and then create transactions, etc., do lots of stuff. But the UI is completely oblivious of this. It doesn't know exactly how the library is carrying out all these things. As far as the UI is concerned, all that the library is offering is a bunch of methods. So the UI is interacting with a system, a set of complicated network of objects through well-defined methods. And the UI doesn't care about anything else. So this behavior of the library is called facade. It is a design pattern. One of the 23 design patterns described in the Gang of Four book that came out in 1996, the original set of design patterns. What does a facade do? It uses a number of objects and orchestrates a show. And for the client or the clients, the client only knows how to interact with the facade. And behind the facade, there is a whole set of objects that have a complicated relationship, and none of that complexity is visible to the UI. The UI is simply seeing these operations, add book, issue book, return book, and so on. Okay, so when you design a system like this, where you have a complicated set of objects, but then you create a set of one or more operations so that clients can use those operations to perform its functions, we are using the facade design pattern. And what you will probably do in your group project is again create a facade for your grocery store. All right. So that is, so this is a good example of a facade. Let me stop here for a second and see if you have any questions before I say a few more things. All right.
I wanted to ask, how are the transactions stored? Are they in a list by itself? Is it connected to a member?
Yes, every member has the list of transactions associated with that member. The reason is you don't need a centralized list in our application because we are only going by member. The only query that we have for transactions is get transactions associated with a member on a certain date. So there is no need for a centralized list. Any other questions? Okay, and if not, let me say a few more things about facade. Tell you about a couple of examples that we all interact with very often. One more than the other, perhaps, but still, as we are all programmers, we interact with both. One is operating systems. We deal with them almost every day. We all use computers every day. And what does an operating system do? Of course, you have hardware, and we provide a layer of software on top of it so that this hardware is, first of all, usable, and the resources are efficiently managed, and so on. So a good analogy is that of a government. Without a government, you can't have a country, right? So an operating system is like a government. And we have programs that we write or we use. For example, we might have Word or Excel or a browser, whatever. They typically use the hardware, but through the operating system. So if a browser needs to communicate with a remote server, it will issue a request which goes through the operating system, and then through that, it is able to access the communication devices that are part of the hardware and send and receive messages to or from a distant server, right? So with most of us, when we write programs, would be using the operating system directly, right? But we know underneath the operating system, there is a very complicated set of devices. We have the CPU, memory, then a lot of buses running among all these different components. Then you could have secondary storage. You could have lots of other types of devices connected. You could have communication networks to which the machine is connected. Managing all that is very complicated. You and I don't want to write programs every day dealing with those things. We want something simpler. That is why we use the operating system. It is managing all these complicated devices, just like the library is managing all those objects. Perhaps the library, the system that is behind the library is simpler than what is in the hardware. That is true, but it's still, the library is a facade, just like this operating system is a facade. Why is this operating system a facade? It is managing all this stuff here, and it is providing a set of so-called system calls. The system calls would be things like start a new process. Maybe it is called fork in Linux or Unix. You might have something called open a file, close a file, exit a process. You could have read a file and so on. So there would be well-defined operations using which these processes can get services. For example, when you issue the fork system call, it would create a new process. The operating system will find memory for the process. It will find space in its tables to accommodate the process, etc. So it is using resources here, but we don't have to know about all that, right? Or when you want to open a file, the operating system has to communicate to the secondary storage device to find out where the file is, and then go to the correct track on the correct device, and then read the required number of bytes and pull them into memory, find space for those bytes in memory and copy them, and then make that stuff available to you. So when you say open or read or whatever, it has to do lots of stuff. But we think in terms of relatively easy functions, or perhaps you could call them methods if you want. Open or read or close or exit. They are much simpler than the kind of things that the operating system is doing, right? So it does lots of interaction with lots of components to do one thing. We don't care how that is carried out in our normal programming, right? So this is an example of a facade. The set of system calls that you are provided with is somewhat equivalent to the set of methods that the library is exposing to user interface. Let me give you one more example before I stop this business. The second example is that of a compiler. A compiler, of course, we know what it does. It compiles programs, right? And it is part of your, what do you call, daily life. When you are doing programming, you can't escape using this stuff. So a compiler consists of several components. I can think of 5 or 6. Let me start with 5. One of the components of a compiler is a scanner. Then there is parser. Then intermediate code generator, code optimizer, and code generator. So when you write a program, you would submit it to the compiler for compilation. You are not aware of all these things. You don't think about all these things. Even if you are a compiler person, You wouldn't think of all these things when you are writing your other programs. All you want is things to be compiled. The scanner reads your program, and if you write things like public class, my class, it will read all these characters. The scanner will read all these characters and then figure out that this is one word and give it to the parser. Then it will read these characters and give the class token to the parser, then my class, then the left curly bracket, etc. So the parser gets things in units of the language, whereas the scanner is reading in characters. Then the parser puts all these tokens, they're called tokens, and then tries to make sense of what is being read. So it knows now that this is public, then there is a class coming in, and then it is expecting the name of the class, then the left curly bracket, and so on. So it sees whether you are following the grammar of the language. That when you use a variable that it is defined, that when you call a method, it is there in the class, etc., etc. And once the parser, or as the parser is figuring out what the program means, there is an intermediate code generator which converts all these Java lines of code into what is called intermediate code. This is not machine code or anything. This is somewhere in between higher level language and machine language, somewhere in between. It is not even assembly code. Okay, so this intermediate code, and it usually comes in triples or three or four parts to that code. It is not as difficult as machine code, but it is more difficult than reading Java code. Okay, and once the intermediate code is created, you figure out if there are any opportunities for optimizing it so that the code runs faster. And after the intermediate code is optimized, you take the intermediate code and then convert each of those intermediate code pieces into the machine code. So one intermediate line might be translated into 2 or 3, or maybe one or 2 or 3, that kind of stuff, machine instructions. And once the machine instructions are assembled, perhaps this can be put on a processor and executed. But the compilation is done. But sometimes you might have a fifth component here. Oops. There might be a fifth component. And that is a linker. So you take the machine code here and give it to a linker, which will link your program with other programs. That may or may not happen. It depends on the language. It depends on so many things. And then it is after linking that you final executable. You get a final executable. Okay. So a compiler is doing lots of stuff, very complicated stuff. But when we think about it, when a compiler, you're always thinking, okay, compile this program and tell me if there are errors, I will fix those. Okay. Sometimes, many years ago, when I used to work more with C programs, I used to do this and do the linking separately using the same system. So I used to think of it as the compiler and the linker. But nowadays with Java, I don't think about the linker at all. I only think about compilation. So this is a facade. Although there is a set of different components that interact in a very complicated manner, and the compiler manages that interaction, you don't get to see it. We are only thinking in terms of one operation, that is compilation. So this would be an example of another facade. Any questions before? I have one more thing to say before I close this. All right. In the library, we have just one facade. It could be that your system is more complicated. You might have multiple facades. Perhaps this deals with bunch of operations, and sometimes you might want to separate some of these operations into a different unit. Then you could have multiple facades for the same system. That is not unreasonable to have. Okay, so this is once again the facade design pattern. That is what the library is. Okay. Any questions? All right. Let me stop sharing. We need to start the class exercise. Let me go ahead and stop recording now. Okay.